SMO 2019 Open Section Round 2 Singapore Mathematical Olympiad. We want to solve the problems and I want to show you how to reach the solution, not only exactly the solution. Step by step, we want to improve our problem solving. If you wanted to know ideas, other ideas, or if you had any question about the solution, as I said before, feel free to send message to my WhatsApp number in the description and comments. Also, if you had any question or if you want to learn other things, subscribe my YouTube channel and turn on the bell to have next videos. Okay, problem number 1. Okay, in problem number 1, in the acute angle triangle ABC with circle omega and orthocenter H, points D and E are the feet of perpendiculars from A onto BC, D here, and from B onto AC, respectively. Let P be a point on the minor arc BC of omega, for example here. Minor arc means here, P. And points M and N are the feet of perpendiculars from P onto lines BC and AC respectively. Let PH and MN intersect at R. Prove that MDR beta equals to DMR, so it is DMR alpha. Prove that alpha is equal to beta. We want to prove this. Okay, so let's work with the angles. I say, okay, it is alpha, so I can say, let me minimize the pen. It is alpha, so it is also alpha. Here it is 90, so we can say they see the same side, PC, so we can say MNCP is cyclic. If you had any question about the solution, as I said, feel free to send message to my WhatsApp number in the description and comments. Okay, it is alpha, it is cyclic, so it is alpha, it is also alpha, because they see the same side. And for example, I can say it is what? It is 180, 90 minus alpha. It is 90 minus alpha, and ACPL is cyclic. These points, ACPL is cyclic, so because it is 90 minus alpha, this plus this is 180, so it is 90 plus alpha. We know it is 90 plus beta, it is 90 plus alpha, so we should prove that y it is equivalent, that y dr is congruent to for solving hard problems, not very hard. It is an important idea always, if the problem is not so much simple. You work a little on assumption, a little simplify or find equivalent to the sentence. Work both on sentence of the problem and assumption. Here we work on assumptions of the problem. Here we said, okay, it's 90 plus alpha. It is 90 plus beta. So if beta equals alpha, then they are parallel. So it is equivalent that y dr is parallel to LP. And here on one important formula, or I can say equality, is that when orthocenter we have DH is equal to DL. It's a famous thing. As I said before, there are around 50 important ideas in geometry. If you had question why it is true, we know DH equals DL. As I said, feel free to send message to my WhatsApp number. So DH equals DL, it is an important formula. So we say, okay, because they are equal, if they are parallel to each other, we should prove that it will be equivalent, that y HR equals HR, let me maximize the pen. It's equivalent that y HR is equal to RP. So our problem is this now. Okay, now let me copy this one, and we want to prove y PR equals RH. Let's paste it here. So I erase. Let me tell you I want to do exactly what. Let me draw the rest of that with pink. I say, okay, if I it is half of this, half of this. For example, if I extend this part, it is what the length 147 and 296, 294. Okay, and then I consider this part, or let me tell like this. I also, it is what it is m until pm is 94, so 188, 188. It will be around this because, okay, I will show around this. Now I say what? So here I say, for example, let's remove this part, remove the things we don't need. So draw mn here, draw this part here, and let's draw this one. Okay, it is Pn, we call this n prime, we call this point m prime, and it is h. So here we define this one that it is equal to this, and this one that it is equal to this one. So I want to say that mn goes through half of this. So because I know it is parallel to this and it is midpoint, if I prove that these two lines are same, hm prime, n prime, if I say hm prime and n prime are collinear, I want to prove this. If I prove that these 3 points are collinear, then this is parallel to also hm prime, and you can say it passed through half of HP, midpoint of HP, and then we can say, okay, HR equals RP. So here, let me erase all things here and see what should we do. And let me also erase this alpha. So suppose this angle is, let me write m prime here. Suppose this angle is theta, this angle is gamma. We want to prove this equivalent that y theta plus gamma equals 180 degree. We know theta equals, I can write this is theta 1, this is theta 2. And let's erase also this one and connect. Right, let's stuff that with green, connect this point to this point, and then I say, okay, it is theta. Also, we can easily prove it is theta, because if you draw perpendiculars, then you say, okay, it is equal to this, and it is 90, 90, and they are equal length. You can say this part. In this part, they are parallel to each other. It will be rectangle here. It will be rectangle here. So these two lines are equal, and then you say, okay, this minus this one, it is this, and this minus this one, it is this. So by two sides and an angle between, you can easily say these two triangles are congruent. So you can say that if it is theta, it is also theta. So let's write this is theta, for example, 1, it is theta 2. So y theta 1 plus theta 2, let me write question mark, theta 1 plus theta 2 plus gamma, y it is 180 degree. I know that because it is midpoint, it is gamma, so you can say it is also gamma. So this angle is 180 minus gamma. And theta 1, we should prove that y theta 1 plus theta 2 equals 180 minus gamma. Here, if I want to write theta 1, I can say that theta 1 is 90 minus this. So it is 90 minus this angle. This angle is what? Half of arc PC. Theta 2 is what? So we can do something. We can say what? It is equivalent that 180 minus gamma minus theta 2. So it is theta 2. So if I want to write exactly this angle is what? 180 minus gamma is what? This arc. Arc AB plus what? BL plus LP all over 2 minus theta 2 is minus BL over 2. So we can cancel these two things. So it is equivalent that y 90 equals PC plus AB plus LP over 2. So let's see. PC is what is this angle? Let me write it with red. PC is this angle. AB is this angle. And LP is this angle. So if we consider this angle, we know it is 90 and it is interior angle. It is exactly C angle CDL. We want to prove this is 90, CDL is 90. So we proved this part and then we proved that it is one line. So you can say if you extend it, it is parallel to this one line, this, and then it passed through. Let me tell you here. I've proved that if you extend them like this, extend like this, and if you connect like this, it will be what they are collinear. We proved if it is equal to this, 1, 2, 3, it is equal to this. So because they are midpoint is parallel to this, it is one line. Also, it is parallel to this. So we can say because by Thayer's theorem, PM over M, for example, M prime, we said PM over M prime equals PR over RH. So PR is equal to RH. And we said, okay, so 1, 2, 3, 4. 1, 2, 3, 4. And then because it is midpoint, so this is parallel to this one. So 90 plus alpha equals 90 plus beta. And then we can say alpha is equal to beta. If you had any question about the solution of this problem, also other problems, as I said, feel free to send message to my WhatsApp number in the description. And SMO round 2, 2019 open section problem number 2. Find all functions f from integers to integers such that f of negative f of x minus f of y equals 1 minus x minus y for all integers x, y. For solving function problems, there are around 15 important ideas. For example, checking for small cases, spatial cases, check is it one-to-one, injective, surjective, something like this telescoping rule. So here, for example, I check at first, is it injective? Is it, we can say also one-to-one or not? One-to-one means what? If f of x equals f of y, we want to see, can we say x equals to y or not? So we want to check, is it one-to-one or not? So if f of x equals f of y, then we can say what? We can say f of negative f of x minus f of y. You can say it equals to what? It equals to f of, let me say, you can say it is equal to f of negative f of x, because f of x equals f of y negative f of x. You can replace f of y with f of x. And if you use now this formula here, it will be 1 minus x minus x. Similarly, you can use here and say, okay, f of negative f of x minus f of y equals f of negative f of y, replace f of x with f of y minus f of y, and if you use this formula, the minus y, so because these two things are equal, we can say 1 minus 2x equals 1 minus 2y, so we can conclude x equals y. So it is 1 to 1. Now we say, okay, suppose we want to consider spatial cases. We have x and y, and then change it to x plus y and y, for example, minus 1. So we can say what? F of negative f of x minus f of, let me write like this, f of x plus 1 minus f of y minus 1. It equals, if you use this formula, it will be 1 minus x plus 1 minus y minus 1. We can cancel these two things. So it will be 1 minus x minus y, and then we can say it is equal to f of negative f of x negative f of y. And then because f is one-to-one function, if f of something equals f of something, you can get rid of the outside f. So we can say negative f of x plus 1 minus f of, because it is one-to-one, negative f of y minus 1 equals negative f of x negative f of y. And then if we take negative f of y to left hand side, f of y minus f of y minus 1 equals, take this to right hand side, f of x plus 1 minus f of x. So we understand what? We understand that f of anything minus the difference of two consecutives, f of two consecutive integers is constant, and we know f is from z to z. So here we say, okay, if we suppose that it is c, so f of 1 minus f of 0 is what? Let me call this one, for example, d. So we know it is c. So f of 1 is d plus c. Also, we know f of 2 minus f of 1 is c, so it will be d plus 2c. And you can easily, by induction, prove that f of n equals d plus nc. F of 0, we said it is d. Let me write here. It was for n that is positive integer. So f of 0, we said it is d. Now, if I want to use f of negative 1, I know f of 0 minus f of negative 1, like here, is c. So you can say, okay, I know f of 0 is what? F of 0 is d. So f of negative 1 is what? Is d minus c. You should subtract by c. So if I write for also negative numbers, I will see what? I will see that f of negative 2 is d minus 2c. So I can say f of m that is negative is d plus m, c that m is negative integer. Also for 0, I will see that it is true. So we can conclude what? F of x equals cx plus d for all x that are integers. Now, I want to use this and assumption of the problem to see what can we say. So it is this, and also if I want to use assumption of the problem here, let me copy this part. So I say f of negative f of x is what? Cx plus d minus cy plus d equals 1 minus x minus y. So it will be what? F of this. F of this will be what? C times this. C times negative cx plus d minus cy plus d plus d is equal to 1 minus x minus y for all integers x and y. So you can see it as a polynomial in terms of x and y, and let me consider coefficient of each of them. If we consider coefficient of x, it will be what? Negative c squared plus 1. Coefficient of y, negative c squared plus 1. And cd minus cd minus cd. So let me say minus 2cd and plus c plus d and minus 1 equals 0. So here it's a polynomial in terms of x and y, and it is correct. It is 0 for infinitely all x and y that are integers. So you can conclude that it is an important famous idea in polynomials that all coefficients should be 0. So negative c squared plus 1 is 0. Also it is that coefficient, and negative 2cd plus d minus 1 equals 0. So here you conclude c squared is 1. So c is positive or negative 1. If c is 1, then we can conclude, if you replace here negative 2d plus d minus 1 is 0. So negative d, take it to right hand side, it will be dd equals negative 1. So it is what? It is cx plus d. So f of x is x cx plus d minus 1. And if c is negative 1, if you replace here, it will be 2d plus d minus 1 is 0. So you can conclude d is 1 over 3. So f of x equals what? Equals cx negative x plus 1 over 3. But here, for example, for the second case, f of 0 it will be 1 over 3. But the problem says what? F of z is from integers to integers. So f of 0 is not integer here. So f of x, x minus 1. And we should check this case. Let me paste it here. Okay. So let's see, does it works? So it will be f of negative f of x is x minus 1 minus y minus 1 it equals, let's calculate left hand side at first. It will be what? It will be f of negative x negative y plus 1 plus 1 plus 2. And we know f of this is x minus 1, so it will be negative x negative y plus 2 minus 1. So it will be negative x negative y minus 1. And on plus 2 minus 1 plus 1. So we see it is equal to right hand side. So this answer works. So we have only one answer. F of x equals x minus 1. SMO 2019 upper section round 2, problem number 3. A robot is placed at the point P on the x-axis, but different from 0, 0 and 1, 0, and can move only along the axis either to the left or to the right. Two players play the following game. Player A gives a distance and B gives a direction, and the robot will move the indicated distance along the indicated direction. Player A aims to move the robot to either 0, 0 or 1, 0. Player B's aim is to stop A from achieving his aim. For which P can A win? Okay, so let's consider some points. For example, player A want to reach to these 2 points, and player A can say what? Player A gives only distance. So A only distance and B direction. Okay, so if the robot is, let me show with, like if it is in this point outside interval 0, 1, then you say, okay, if B say direction to right, always to right, then A will lose. So points here, all of them are bad. Also here, then B will say what? B will say left, and always it goes left, left, and can't reach to 0, 1. Also here, right, right. So all these points are bad. And the point is different from 0, 0, from, it means 0 we consider x-axis. It's different from 0 and 1. So here, for solving this problem, as I said, one of the most important idea, especially in combinatorics, and also is important from qualifying level in SMO and other countries, and also IMO international level, is to consider a small example. But sometimes it's not so much easy to find. We should use a small example on what. Here, if we use a small example, suppose that A win, we want to consider these cases. Let's consider that we want to say a small example of the minimum number of steps that A can win. So in first step A can win, A says what? A distance, and B with says this direction. In this step, if A wins, means if the point go to left or right, he wins. So it should be midpoint. So midpoint is good, because if the first point, because if P is 1 over 2, I don't write 0, 1 over 2. 0, 1 over 2, I means it's 1 over 2. So then it is not important that P says left or right, he wins. Now, so it is the point that in that step, finally he wins in after one step. So if A want to select a point that wins at the end, we can say at the end B, it is not important B says what direction, he should reach to this. So it was the, for example, 0 step, then it is 1 step. So if we reach to each of them, we can say, okay, he wins, A wins. Now consider this midpoint. So it is 1 over 2, it is 1 over 4, it is 1 over 4. And then we understand, okay, it is 1 over 8 midpoint of this, midpoint of this, midpoint of this, and midpoint of this. Oh, sorry, let me tell you, 3 over 8 is 3 over 4. It will be 3, 5 over 8, and 7 over 8. So if you consider, it will be something over 2 to the power of something. So we want to say the cases that A wins are these points A over B, such that A and B we know are positive integers, and A is strictly less than B. And let me write other condition. B should be a power of 2. B should be 2 to the power of alpha. I want to say only in these points A wins, and in other cases A cannot win. So at first we should prove if P belongs to W, then A wins. Our claim is this. Then A wins. How we prove it? We prove by induction on alpha. We prove by using induction, and alpha is, let me tell you, alpha is a positive integer. Induction on alpha. So base case, if alpha equals 1, so it is what A is positive and less than 2, so only we have 1 over 2, and it is midpoint, we proved. So A should be what? A should say the distance should be 1 over 2. It is not important that the direction is left or right, it wins. Now suppose that we prove, for example, for 1 to alpha minus 1, and we want to prove for alpha, and alpha is at least 2. So we have a point here that it is b a over b to the power of alpha. So we select, we know it is not exactly 0 and 1. So we consider 1 over 2 alpha, and this one also 1 over 2 alpha. We want to use this distance. So if one of them reaches 0 or 1, then the problem will be solved. Why? Or we can say if both of them are 0 or 1, then if player B select that direction, A wins. So consider these two things, A minus 1, 2 to the power of alpha. And let's simplify. Suppose that without loss of generality, suppose that A is odd. Also here you can say this. A is odd. Because if A is even, you can simplify more. So A is odd, and then we can say what? We consider A minus 1 to the power of alpha and A plus 1, 2 to the power of alpha. So here it will be what? A minus 1, because A is odd, A minus 1 will be even, so it will be A minus 1, 2, 2 alpha minus 1, and A minus 1 over 2, 2 alpha minus 1. So both of them, if you pay attention, it is integer, and you can easily prove if it is not, if it is 0 and the player B select that, if one of them is 0, 1 and player B select that direction, A wins. If he doesn't select that, we can say each of them is between 0 and less than 2 to the power of alpha minus 1. And now here, if you see, here is alpha minus 1. So maybe A minus 1 over 2 has more even numbers. So if it was like this, you can divide more. For example, suppose a V2 of a number means the maximum power of 2. For example, it is x, or it is, for example, t. So you say a minus 1 over 2t, and t we know is at least 1, 2 to the power of alpha minus t. So it is positive integers, and it is odd, and you say, okay, it is odd to alpha minus t, you say, okay, it is at most alpha minus 1, so we can use induction and say, okay, it can reach 0 and 1, and player A wins. Otherwise, if P is not in W, we want to say that player A can't win. Okay, for this part, we say, okay, if we consider it is 0, it is 1, and okay, so we want to say A can't win, and we want to say player A or robot can't reach to a point in W. So we say, if we prove that he can't reach to W, so he can't reach to this point 1 over 2, so always B has a good direction. That's and A can't win. So I want to say, suppose that, for example, the robot is in this point, this, for example, PI in, for example, ith step, and player A on. If P is here, we prove that always he say right, and he can't win. If he's here, always B say left, and he can't win. So P, for example, is a point here. Suppose, for example, in ith step we have PI, So, and a say distance. We know the distance is not the case to go outside this interval. And it is what? It is, for example, the length is L. I want to say at least one of them, for example, suppose at least this pi is, for example, let me write like y, or let me say, for example, it is e, this e plus L, e minus L. I want to say always at least one of them is not in W, e plus L or e minus L. Suppose e plus L belongs to W and also e minus L belongs to W. We can say 0 is also, we can write it. Okay, so let's at first consider, we want to say that both of them are not in W, and then we say consider also the case that we are, one of them goes to 0 or one of them goes to 1. So you say if both of them are these, so e plus L is what is a1 over 2 to the power of alpha, for example, alpha 1, and this one e minus L equals a2 2 to the power of, let me call, for example, this one beta 1, and this one beta 2. So we say what? We say if we add up these two numbers and divide by 2, it will be e equals a over a1. Without loss of generality, suppose that beta is at least beta 1 greater than equal beta 1. So we say what? It is a1 over 2 beta 1 plus a2 over 2 beta 2 over, we can say 2. And then we say, okay, it is what? It is, and e is between 0 and 1, so numerator is less than denominator. So if you divide, it will be a1. We said beta 2 is at most beta 1, so 2 beta 2 minus beta 1 plus a2 over 2 beta 2 plus 1. If it is not odd, we can simplify. So we said E belongs to W, and that's a contradiction. Belongs to W, and that's a contradiction because we wanted to see the first time that we reach both of them are W. So B can do something that robot can't go to points that are in W, and let's consider if one of them is 0. If one of them is 0, let me copy this port. It is similar. If one of them is 0 or one of them is 1, we can reject it. Suppose in, for example, this case, E is here, and it is L, it is L, so A plus. If this one is in W, I want to prove it is not in W. If E plus L is in W, then you know what? You know E minus L is 0. So you can say E equals to L. So you can say E plus L is 2E belongs to W. So you can easily say E over 2 is also belongs to W. So 2E equals to, for example, A3 over 2 beta 3. So E equals A3 2 beta 3 plus 1. If that's by the conditions of W, it's contradiction. And the last case we should check is when one of them is 1. So when this happens, L for previous case, B select right direction. And if E is near to 1, you can say what? It is E, L is here, E minus L is here. So if E minus L belongs to W, if E minus L is an element of W, then we know E plus L is 1. So we can say E minus L is, for example, A4 2 to the beta 4. And you say what? You say L is 1 minus E. So if I replace here, it will be E minus 1 minus E equals A4 2 over beta 4. Then we can say, okay, 2E equals A4 plus 2 beta 4 over 2 beta 4. So you can divide by 2. It will be 2 beta 4 over 2 to the power beta 4 plus 1. And we see, okay, it has the same form. Also, you can say this is less than this because E is between 0 and 1. And you can say what? You can say it has the same form, so it is W, but we said we want to consider the first time that we reached to W. So E was not in W. After E, we want to say we have no choice to reach W. So when we have these things, we are sure that E minus L is not in W because E is not in W. So we select L, left. Here you select right. In this case, player receives which of them? If we select, then A can't go to the element in W. So we proved if the first point is not in W, always player B can select the direction that player A can't go to W. So if P is not in W, A can't win. If you had any question for solving this problem or also other problems, as I said before, feel free to send message to my WhatsApp number in the description and comments. Also, I released part one of I released some problems of senior and also open sections of 2019 and junior of 2019, all problems. Also, I will release another years, another sections, another parts. If you had any question about any problems, you can use my video, improve your problem solving, or if you had any question that were not in my videos, you can send a message to my WhatsApp number in the comments and descriptions. Also, please subscribe my YouTube channel and turn on the bell to have next videos and improve your problem solving.